Thank you all, obviously, for being here. I understand that it's Friday morning. I understand you're all flying home soon. I'm sure many of you had several very tasty beers last night. And now we're going to talk about Dataflow. So we're going to have to hand out free things for all of you that stay awake the whole time. But I'll dance and do some things if we need to. So what I want to talk about today is a project that was started quite a long ways back. It's been used for a really long time at a very large scale in production. But only 7 months ago went to Apache. And what we're talking about here is Apache NiFi. And I'm very happy to say Apache NiFi without any parentheses and the word incubating, because as of a few days ago, it became a top-level project at the Apache Software Foundation. So we worked through the incubator, sort of established that we understand the Apache way, and here we are. So for those of you that want to participate in the demo, if you could send a tweet to @Apache NiFi, we're listening for those, and it'll help me to illustrate some key points so that you can really understand what we're talking about when we say kind of enterprise data flow. And really, before I dive into the basics of NiFi, or like the core concepts, what I want to do is help frame what we're talking about in terms of this kind of global data flow problem. And I specifically want to start by talking about messaging systems, because in my experience, that's what a lot of people gravitate to when they think about data flow. They think about what messaging systems do and the kinds of things that they solve. And so I want to kind of make the case for why there's a lot more to this problem than messaging. Okay, so what we're starting with here is an excellent graphic made by an artist, of course. We have systems that acquire data, whether they're sensors or business systems, organizations that are gathering data for your business. Think IoT or big corporation. That information is being collected or acquired. It needs to be sent to processing systems, analytic systems. Think MapReduce, Spark, Storm, all the fun stuff. And then ultimately it needs to be driven into databases where users or other systems can query it and drive further business value. And so in the middle, very common, you'll see these diagrams that show this like simple tube in the middle, and hey, systems put data on there, other systems pull it, and it's just sort of everything works, right? But there's a lot of use cases to consider to that kind of make some of that a bit more challenging than those pictures tend to articulate. One thing to think about is remote sensor delivery. So as IoT sort of expands and becomes more real for more people, what you're going to have are all of these locations where data is captured, think like oil rigs and other things, where they're capturing data about what's happening, how efficient it is, whether it's working, pressure, and all sorts of things. That information needs to feed back to warehouses and places where that data can be processed and turned into kind of business value. And they have to go over, very often, highly constrained comms pipes. Highly constrained can mean a lot of things. It could, in fact, mean that there's very limited bandwidth. It could mean that there's power issues. It could mean that the comms are just sort of inherently kind of up and down. And so there's interesting challenges to consider there. It's not just to put it on the messaging bus and everything will be okay. You also have the more obvious space people think about, which is going from data center to data center. Or within a data center, how do I orchestrate the flow of information between those systems? Think of that as sort of the enterprise kind of problem. That's applicable to, frankly, a lot of industries. And then you have what's really often talked about today as an ingest problem. And a lot of times when people say the ingest problem, what they're talking about is data shows up at the front door of Hadoop, right? And how do I feed it into MapReduce jobs or Spark jobs? And so in general, how do I ingest into a given system? But this has been around forever, right? Whether it was Oracle or Teradata or whatever the database-y sort of system you had, they all had this sort of fundamental ingest problem. In addition to this kind of move it around problem, there's also just a fundamental need to process data, whether it's doing enrichment or transformation or filtering. And so we want to have effective ways to do that as well. And when I talk about data processing, specifically when I talk about it for NiFi, we're talking about simple event processing. Generally what that means is you have a discrete object and some facts or context that you know, and you can do something about that. It is different than complex event processing, which generally you can think of as things that involve time-windowed operations, where you're looking at a series of objects at once and making some higher-level assertion. The space that NiFi fits into, the typical sort of data flow problem for processing, tends to be about simple event processing, less about complex event processing. As you move towards that space, think Spark and Storm and other systems which are built to do that. So the challenges that we face, what are the things that kind of made us build NiFi? Why didn't we just use existing open source tools, or why didn't we go buy commercial tools? And I'll tell you, we had the ability to buy pretty much whatever we wanted. But those things didn't solve the fundamental problems that we saw. One is that messaging only addressed a subset of the challenges that we had in Dataflow. I'm going to spend the next several slides talking about that, so I'll come back to it. The other thing is we needed to understand the big picture. How do systems all throughout the enterprise connect right now? I want to see how the data is flowing. More importantly, I need to be able to make immediate changes at times. It's not something where I can test it out in a test environment. Maybe it gets promoted to like an integration space, and then a couple weeks later it might go into production. Sure, there's cases like that. But the predominant situation we had is there's data flowing, there are systems online, and we have some opportunity or risk that we need to be able to deal with. And so we wanted to be able to immediately affect change. To be able to immediately affect change, you have to be able to see and understand how the enterprise connects. The next thing that was really critical and frankly very different than what was happening in any of the products that we saw, and truly is still today a bit of a problem, is we needed a very fine-grained, high-fidelity chain of custody capability. No matter where the object was created, no matter what we did to it, whatever we learned, if we transformed it, split it apart, combined it, sent it somewhere, we had to know that. We needed to maintain this positive control, chain of custody. And when we were done with data and we dropped it, that needed to be known as well. Related to that is this just general hyper-focus on security and compliance issues. And so we needed to be able to make sure that whenever the system was interacting with data, or people were interacting with the system, or people were interacting with the data, we needed to record that. We needed to authorize that. Not just at sort of a broad level, but precisely between that entity and the data itself. So really fine-grained authorization. So now I'm going to talk a little bit about messaging, just to make what I'm talking about, frankly, more clear. So I'll start by pointing out that there's a lot of good messaging tools out there already. Things like Kafka and ActiveMQ, commercial solutions, they have solved that messaging problem, for which there are still very good use cases, and they've solved them very well, right? But if you sort of back it out to this general data flow problem, I would make the case that they don't solve that very well. And so to sort of articulate that, imagine the ultimate sort of Chuck Norris of messaging systems, right? It has absolutely no latency at all, right? If you give it a message, it is available to any consumer instantaneously. So take the whole latency argument off the table for that broker. It's awesome, right? It also has perfect data durability. If you have n number of brokers, you could lose n-1 and it's perfect, right? Perfect durability, that's great. And it can support an absolutely unlimited number of consumers and producers, right? Just the ideal broker. You give it a message and it's available to somebody else. So if we think back to that connecting the enterprise kind of problem, what are the things that we still have left to do, right? And so you can kind of think through this in a series of questions. And so if you're a producer or a consumer, think of it from that perspective now. I'm a consumer. Some producers put data on a topic. And I'm thinking to myself, hey, look, that format or schema, that's not what I need. I need a different one. My system has been upgraded. It supports the newest, latest enterprise version, totally different from what the producer's doing. Or the alternative is true. We have some new producer that got deployed. It supports a new schema. My backend supports an old schema. What do I do now, right? Or I need to use a different protocol. If I'm a producer, maybe I can't push. Maybe you need to come pull it from me. If I'm a consumer, maybe you can't push to me. Maybe I need to pull it from you. Or I have some legacy protocol that's been around for eternity, and it can't go away for now because we have some really rigorous compliance requirements, or whatever the case may be. It's a real problem. What do I do now if I have this gap? The other side then, or sort of an additional thing to think about is different systems. Both think just purely on the consumer side. This problem exists everywhere, but just think on the consumer side. You could have multiple systems side by side, kind of in an architectural diagram sense, who have completely different priorities, right? Some system may want to see it in the order the events occurred. Another system may want to see the most important information first. Think of an alerting use case, right? There's a stream of observations coming in. If you have a system that's going to be doing some alerting or flagging for users, they don't really care what the last half hour of temperature readings was. If the building's on fire, they need that one, right? And so prioritization is a really important topic as well. And it becomes extremely important when you think about those IoT cases, where you have these sensors distributed throughout the enterprise. They could be very far away. They could be over constrained comms. Comms go down all the time. When they come up, are you getting the most important information first, or are you just getting it insertion order? The other side of this then is sort of data size or data rate issues. Typical messaging systems are actually quite nice for controlling rate, or basically dealing with the gap between the rate a producer might make data and the rate a consumer might make data, because they're sort of inherently buffered. So that part's pretty good. But what about data size? If you have really large objects, are they going to help you, or do you have to have really small objects? And you can think about consumers that have different needs. Hadoop doesn't want you to send lots of tiny objects. It wants you to batch it together and make larger objects, right, to be more efficient for the name node. Other systems don't work like that. And those are things which kind of change over time. Those are things that architects of each system are making different trade-offs for very good reasons. The Dataflow system has to understand that. It has to be able to support that. Because at the end of the day, the job of the Dataflow system is to make sure that producers and consumers can be good at what they're good at, right? It's all about loosely coupled, highly cohesive systems. Continuing along this theme is, we have different authorization needs. I don't want to just give somebody access to, or a system access to a topic, and they can see everything on it. Some data is more sensitive than others, and if it is, then what I have to do is make more topics, right? And you could have different systems that have different authorization needs. There's also the issue of interest. So if you take authorization off the table and just say, hey, look, every system can see every data, not every system's interested in every piece of data. They don't want to have to troll through all the objects to find the ones that they're necessarily interested in. There's cases where they have very specific needs. And while the messaging broker may be absolutely perfect in its latency, it's certainly not going to be true that all the other systems are. And so these things add up, right? Final point there, or final example to think about, is I'm an analytics system, and I'm going to be running analytics. Maybe I need the data already enriched when it gets to me. I'm going to be doing geo-enrichment, or I need some reference data sets applied to the data as it's coming in so I can have information tagged on it that my enterprise already knew. I don't want my analytics system to have to go out and find all that information. The data needs to be ready to roll to be analyzed right then and there. So what do you do then? If you have this messaging-based architecture, even if it's incredibly fast, what do you do? So you have to add new systems to handle the protocol differences, or maybe new adapters, but then you need a place to run those adapters. Maybe it's the client, but there's a good chance you can't alter the client, right? Because the reason those clients exist the way they are is because they've been around for longer than this new system you're working. And so you have to put a new system that pulls via the legacy protocol, adapts it to the new one, right? Somebody's got to maintain that system. It's another ops team, or maybe they have a platform they can add it to, but these are things that you keep adding that are outside that messaging space. Not to mention the fact that you're doing RPC calls in and out every time you're talking to these topics. Fine, the broker may be super fast, but your system does have latency. And so you also have to add systems for the conversion case. You have to add new systems to reorder data if you have priority concerns. You have to have somebody pull off the topic, reorder the data, and write to a new topic. And this kind of goes on. And what this ends up meaning is that it essentially causes a lot more complexity. Not in the messaging broker. The messaging broker is awesome. It's super fast. But you add complexity throughout your enterprise because you're building all these new systems and maintaining all these new systems. And ultimately, at the end of the day, the people that suffer because of this are the operations teams. The developers are happy, right? They like writing systems. But the operations teams now end up having to maintain all these new systems. They have a lot more logs they have to run through to piece together and understand how the information flow works. It becomes very, frankly, painful. So with that sort of pretext in mind, I want to talk about NiFi, which was built to it was built to go beyond what the messaging systems gave us, right? Because at the end of the day, we wanted to be able to respond to those issues without having to add new systems. We wanted to make it super simple for operations people to manage the flow of information and make changes in a safe and sort of reliable way. And so key concepts that we're going to talk about here briefly would be the interactive command and control, and exactly what I mean. The ability to do this data provenance, data lineage, chain of custody. There's like a million words we're trying to come up with to make the most sense to people. What the platform itself is, how it's sort of built for extension. For those of you who like kind of the conceptual stuff, flow-based programming is there's a nice wiki page for it that kind of describes the concept. NiFi very closely mirrors the sort of concepts that they talk about in flow-based programming. And then, how do we achieve high performance? How do we deal with, frankly, extremely high scale on a relatively small number of nodes? Or, another key point to kind of understand there is scale is not just out. Scale down still matters, scale up still matters. And if you think about scale up, what we're talking about is that each node is able to do something efficient. That it's not just dozens or hundreds or thousands of nodes that don't do much, right? We want them to be efficient so that when you scale out, you're actually adding more value without increasing the load on the operations guys. Quick thing to understand the architecture. This is obviously a very basic diagram, but the idea here is that each NiFi node, and they can run in a cluster, we can talk about that at some point. It runs on an operating system. On that operating system is a JVM. NiFi is running inside the JVM. NiFi today is all written in Java. We do support some of the other languages, particularly because the JVM supports scripting languages, but also because we can make system calls, or there's processors to invoke system commands. We have a web server because all interactions with NiFi go through that web server. If you want to control it, if you want to make changes, if you want to see the state, if you want to get status information, all that goes through the controller. And so that's what that web server is there to do. And then we have the flow controller itself, which its job is to execute tasks. Those tasks are processors in the flow. This will make a lot of sense here in a second. And so think of it as like a thread pool, a managed kind of task executor. We then have the 3 repositories, and these are really important to understand what they do. The bottom left one is called a flow file repository. That's just metadata about the objects in the flow. Maybe what's a name, a UUID, timestamps of when we initially saw them, attributes that we've learned about them. Think of that, as I talk about these next 2 things, flow file and content, think of it like HTTP, where you have headers and payload. You can sort of think about the flow file repository as being where the headers go. And, oh dear. And the content repository being where the payload goes. That payload could be 0 bytes, it could be many gigabytes, whatever. The third piece, which is really important, is the provenance repository, and that's basically the traceability information. This flow file became that one, this attribute changed from A to B. Again, things that will become more concrete. These are resident on each node. So if you're in a cluster, you have multiple nodes, each node's doing its part, right? And the reason that this is really important is we don't want to be making remote procedure calls out to some third-party messaging system because we are manipulating the data constantly. We're asking questions of the data constantly. And we don't want to be holding that data in memory whenever we pull it off the broker. These are the reasons why today, when you deal with these systems, you have heap problems because you're reading those objects off of these queues into your system's sort of heap space, because where else are you going to put it unless you do your own sort of local storage mechanism? You manipulate it and you write it back. This is why in almost all those cases you end up dealing with small messages, or they promote small messages, or they tell you, hey, you need to make your data fit what our system does by splitting it up for us. It doesn't really make a lot of sense. And so this does not force you to deal with only small objects. And for us, there was data that you couldn't split like that. All right, so let's look at NiFi because it makes this a lot more fun, frankly. All right, so what I'm bringing up here is my web browser. I am connecting to a system that we have running on EC2's Eastern Zone. It's 2A SSL, so when I go to that system, it's asking about me. It's pulling my cert information. I'm getting its cert information. We're doing a little trust handshake, and now every operation I do, it knows who I am. This happens to be an acquisition node, or we're calling it an acquisition node. Think of that as like a remote data center capturing data. This is a very confused company, as an example. What they're doing in this sort of hypothetical scenario is they're capturing network traffic, medical records, the Twitter feed. There's a stream of photos coming in, some enrichment data, and there's some interaction between Spark because we're capturing provenance data in this case. But the key point to understand here is we're looking at the live flow and what's happening. So I'm just going to dive into one that's really easy to talk about. So what we're looking at here, is that visible, hopefully-ish? All right. So what we're looking at up there is we're pulling 3 different feeds from Twitter. We're getting the garden hose, which is roughly 1% of the tweets. We are listening for any tweet that has Apache NiFi in it, and we're listening for any tweet that talks about OSCON. What I can tell you definitively is in the last 5 minutes, there's been 49 tweets about OSCON, or that had the hashtag OSCON. And they were a total of 289 kilobytes in size. Pulling that from Twitter took us exactly 38 milliseconds, okay? So and I'm seeing that because these are the metrics that I'm getting right there live on each process. That's a rolling 5-minute window. We also have stats that go over a much longer period of time, but these are things that I, as an operator, can very quickly understand. And this is the actual data flow, right? So I'm in my browser. I see that once we pull in each one of these tweets, we're just dumping them into this evaluate JSON path processor. What that guy's doing, I'm just going to look at some properties. What that guy's doing is evaluating JSON path. So tweets come in as JSON. I go into each of those records, and I'm pulling out things I care about. Each tweet's like several kilobytes. I don't care about most of it. I just want to know the name of the individual that sent the tweet. I want to know the text of the tweet itself, and maybe the language, right? And I might pull the language because I might want to do language translation down the line, which we are, in fact, doing in this flow. And so what I also get to see here is what happens when bad things occur. And bad's really, frankly, very relative, right? It just depends on the state in the flow. It's not, hey, look, a bunch of things are connected together and a bad thing happens, so I just go to a generic error handler. At each state in the flow, I can decide what success means, what failure means, or in this case, unmatched means. And here, if there's a failure with evaluating JSON, we're saying terminate the data, we don't care. Or if it's unmatched, we terminate it. But you could just as easily in your system say, look, failures I need to do some additional triage on. I want to make sure that goes off to some dead letter queue kind of construct, and operations people will check it out. That's stuff that just you configure. I'm going to copy this flow to show you. So you can't alter an individual component while it's running because we don't want you to be able to put it into an inconsistent state, but you could stop that and edit it. So I'm just going to copy and paste that processor on here because I want to show you this piece. So what I can do here is I can set the scheduling strategy. This would be whether it runs concurrently, like in this case we have 4 different threads running, or whether I want it to be single thread, or timer-driven, event-driven, or cron-driven. Timer-driven just says run based on every so many seconds, or milliseconds, or whatever you might pick. In this case, we said 0 seconds as the run schedule. That translates to run super fast. But you could tell it to run every 5 seconds, 10 seconds, whatever's important to you. The other part on here that's really important, okay? For those of you who have been dealing with this kind of space, you understand that there's a fundamental trade-off that you're making, no matter whether you want it or not, between latency and throughput. That slider lets you make that decision in the flow at the points where it matters to you, okay? And so in this case, we're saying, for people building that evaluate JSON path processor, they think their sort of mental model while they're writing code is I'm just dealing with a discrete JSON message, I extract the attributes I want, and I say success or failure. But what NiFi then says is, okay, I've committed their session. I'm now going to batch a bunch of them together. I'm going to batch as many as I can over 25 milliseconds. This is kind of like the micro-batching sort of story, right? Where kind of it is, right? It is micro-batching. And so they can choose how much time they're willing to let the framework take to try to batch that up and be more efficient. And so instead of doing maybe a few hundred or a couple thousand per second, you can now do tens of thousands per second, as an example. You also have all these properties that you can set on each processor. These are custom, or these are specific to each processor. There's all this documentation right in line with each one of them, where if you hover over the tooltips, it tells you what that property means for that processor. This all happens naturally as part of the API of building these components. All right, so in this case, this is going into each JSON message, pulling out the language. These are JSON path expressions, pulling out the user's screen name, the identity or the identifier of the tweet itself, right? So Twitter puts a UUID in there. We pull that out, the text of the tweet, and the username. Those are now attributes of those flow files that we can use. Once we've done that evaluate JSON path, we then run this router. It's called route on attribute. And if we look at the configuration, all it's doing is running an expression language statement. It might be hard to see. It says twitter.message is empty not. It's funny grammar. So what we're saying is if the Twitter message is not empty, then route it on. If it is empty, then it's not a tweet. And there's a lot of tweets that come out that are not, in fact, tweets in terms of like text, right? And so specifically, you could look at this and say, over the last 5 minutes, there's been 16,423 tweets that came from Twitter, and 14,584 of them actually contain text, right? So those are 140 characters of fun. That then forwards on here, and then goes on down the flow. And I'll show you that as we talk about provenance. But one thing I wanted to get the point across, Let's say that you want to start manipulating this data flow. This is your production system where your boss will punch you if you break it. And so you don't want to mess this up. But what you'd like to be able to do as an operations person who's trying to kind of move the ball downfield is you want to be able to run a developmental flow. You want to be able to test some new idea you have. Maybe you need to start encrypting the tweets and delivering to some downstream system in a lab, right? But again, you don't want to harm the production feed. So you could do something like drag from the top left onto the graph. I pointed at my laptop. I'm sure none of you saw that. So in here, once I've dragged that processor onto the graph, it just gave me a list of all the processors. These are like capabilities to manipulate data or to go get data or to push data. And so in this case, we see there's 85 of them in the pile. And so I want to search for something that does encryption. So I just start typing ENC. I see we can do some base 64 encoding, or in this case, create Hadoop sequence files. It's just searching based on what I typed. I can also do encryption, so that's the one I want. So I'm going to grab that. And now I have this guy. I don't know what it does, so I'm going to right-click and say usage, and it immediately takes me to the documentation for that process, again, built largely automatically based on the API. So for a developer, it's very quick to make new capabilities and then end up having, frankly, a really nice user experience. And so this tells me what it does. It can encrypt or decrypt data. I can pick the algorithm or encryption mode that it uses. I can put in a pre-shared key and some other details, right? So that's really helpful. So let me set that up. So I'm going to do encryption. Nobody look, right? OSCON password, very secure. Once I've hit that in there, it's never again going to be on the client side. This processor is flagged that attribute's sensitive. There's this one moment where it's typed in on the client side. It's now gone to the server. It's encrypted server side. It knows never to send it back. Even when it's sharing information about the flow, it's never back in clear text form. And we have these other attributes, but I don't need to set any more. And I'm going to hit apply. I then have my web scale flow that I like to demo, which we'll just say is update attribute. And we're just throwing this on here. Think of this as like delivering to a system. This is the DevNull processor. So hit success. When encrypt content fails, I want it to loop around because there's no reason it shouldn't work. It could mean that there was some system fault at the time or whatever. So in the case of failure, I'm just going to tell it to loop. And if for some reason it can't handle the delivery of data within the right amount of time, so let's say within 10 seconds, if it hasn't figured out how to recover the failure, then start purging data, right? Start throwing that data away. I could also do a back pressure mechanism here, which is to say, if I get 5 of those in the failure queue, stop letting new data come in. That then propagates the back pressure to the next stage. You could also have back pressure there. Ultimately, that can propagate all the way back, if you want, to the source of data, to where you stop bringing in new data. If you're a data flow system, you have a problem. There are systems firing data at you, and you're beholden to hang on to it until all the consumers get it, right? And so one way to deal with that is through a back pressure mechanism, which is you will eventually stop accepting new data. You may say, look, I can't do that. In my organization, that's not an option. The broker just always has to take new data. Fine. But you are making a decision somewhere. You're deciding whether to accept new data or whether to purge existing data. You're picking one of those two. NiFi lets you make that choice. The other thing is each one of these relationships becomes a queue, right? It's a natural point in the system where data can build up. Those queues need to be able to be prioritized. And that's what this mechanism here is. You can pick and drag onto the graph, whether it's first in, first out, last in, first out, based on some priority attribute, whatever scheme that you have that's important for you. And so I'm happy with this. After 10 seconds, throw it away. Failures now loop. In the case of success, send it to my super fast system. We're good there. I can start that guy. I can start him. These guys aren't doing anything fun. They're just sort of sitting there spinning around. They need data. They need the tweets. And so I have my production flow. I'm going to click and drag and connect anything that matches. Actually, and I don't want to disturb production either, right? So I need to consider how am I going to handle this connection here too. So if my encryption isn't fast enough, throw it away after 5 seconds. And if I get a backlog of like 5,000, I want to stop bringing in the production feed. This is a hypothetical scenario. You could put it at 5 million. You could put it at a really large number, whatever is important to you. So that's on. I've connected that, and now you see my developmental flow is up and running, and I know that production's fine. And the reason it's fine is because of those content repositories, or the repositories I was telling you about on the previous slide. I don't have to make copies of the data. I don't have to increase the load on the system in terms of putting copies of data. It's not moving from one topic to another. These are pointers. So all I did there, right? So when the relationship went from the evaluate JSON path to my encryption processor, all I did was make a new pointer, pass by reference. Once I've actually manipulated the content, right, I ran it through this encryption function, I then did copy on write. I took the original tweet that's going down the production line, I read from it, and I wrote to a new content claim, okay? And so there I made a new version of the content. I'm recording information about how that occurred, how long it took, which process did it, all sorts of details. So if we were to go look at the lineage graph for that, let's see if anybody sent any tweets. This is always the awkward moment of the demo. So this is provenance. I don't want to gloss over that too much. So this is the provenance listing. In this case, we have about 52 million events indexed. This is a single node, not a lot of storage. That number can go quite a lot larger. And so I'm going to search through provenance. I am indexing the Twitter messages themselves, right? You can select which attributes you want to index. So let's search for any event that has @Apache NiFi in it, right? And so I'm just searching for today. I could constrain it to be a shorter time window. I'll go ahead and do that, actually. Actually, we'll just search. Think of this as select star @Apache NiFi from Big Table of Fun. So we see 266 events that matched, okay? And the most recent one occurred 10 minutes ago. And I can see that right here because we have these timestamps. So I'm going to look at this attributes modified example. And so I know from clicking on that, I can see the time that that event occurred exactly, right down to the millisecond. I know that at that point in the flow, that object was 3 milliseconds old. I have the UUID of that object as NiFi is tracking it through the flow. I know the component that this event was created by, this provenance event was created by, the processor that did it, whatever its name and type was. And then I know the attributes. So thank you very much, Rahul, and I hope I said that right. So Rahul Chat sent a tweet 10 minutes ago saying, Apache NiFi looks like a good solution for enterprise data flow problems. Thank you for not writing something inappropriate. This has not always gone super well, mostly because of Sean. So I know his username, the exact handle, the exact text of the tweet, but that's not enough. I want to see the content. And specifically, I want to see the content at the flow at that exact point in time. Not what happened necessarily after it, but right at that moment in time. So I have this content tab. And so I could download it. That's no fun, because then I need to have other tools. Or I can click View. And right there in line, it's showing me the tweet itself. This is the actual JSON that came from Twitter for Rahul's tweet, right? And I apologize if I am saying your name wrong. So I can see exactly, here's the text. I know my JSON path that pulled that out. We saw it in the attributes. Here's all the fun stuff that Twitter gives us whenever they sent a message. And I don't actually care about all that. I just wanted his text and his username and maybe the language that it was sent in. And so there's all this stuff, but I can now look at the details. Imagine if you're doing a transformation step and you didn't get it right. Let's say I had the wrong JSON path, right? What I can do now is go back into the flow and fix it. I can change the configuration so that it pulls some other value out. And I can go and I can click replay, because I have the content and context at that point in time. And I can say, fix a configuration, now replay that object. Now I get a new provenance trail for that object, and I can just sit there and keep iterating until it's perfect. Not some goofy cycle of copying the content off, getting it into the lab, playing around, getting it right, pushing it back out to production. I mean, like, right now, iterate until it's right. But this isn't that fun. You could build something like this with a logging system, honestly, right? You could build an index to content. You could grab logs and put them in a system and store them. And your ops people could do unfun things. What's fun is when you can do something like this, when you can tell it to compute the lineage for you. And so now I get to see the trail. I don't have to go dig through logs and like match up IDs. It's doing that for me. And so I can see the tweet as it was received, when we modified attributes, when we made a routing decision, when we cloned it. That's interesting. I would like to expand that. And so now I can see one path that it went down and got sent, and I can see the other path it got sent. What's happening here, I haven't shown you the whole flow yet, and time is a little tight. So what happened there is the data went to Spark, because we're doing some sentiment analysis fun that I'm happy to show any of you afterwards. And then we have another flow where we're delivering it to our processing system. So we all like to say Lambda. It sounds cool. Let's see what we're talking about there. I have the tweet that went from this acquisition system over to this processing system. Now I'm looking at a cluster. This is another set of nodes running on Amazon. This happens to be 3 systems. And I want to find his tweet. So I'm going to do this again. And now I'm going to do that really goofy select star kind of equivalent query against 1.5 billion 1.5 billion provenance events. So star add Apache NiFi again. And we could constrain it with other stuff, but let's just do this. It federated that query out across all the nodes for me. There could be a lot more nodes, and there could be a heck of a lot more events. But here's the ones. This is a new tweet. This is going to be dangerous. I'm not going to do it. Too scary. Now that I told you the trick, I know some of you. Here we go again. So we have his tweet. You can see it's the same text. We can match it up by ID if we need to. And again, we have the content. But now I want to know what happened to it on this system. So I'm going to tell it to compute the lineage graph for me again. Receive, made a couple of routing decisions, and I cloned it. And I cloned it because Lambda's cool. I'm going to send some to Hadoop that needs to be batched together, and I'm going to send some right away to Kafka because it's fronting Spark, or maybe I'm sending it directly to Spark, or maybe I'm sending it to Storm, no offense to whichever is your favorite. In the NiFi world, we love them all equally. Feed them, let them do awesome analytics, and let's move on, right? And so that's what this clone did. It then went to a join. I'm going to expand that join because I want to find that tweet in HDFS, right? That's a perfectly reasonable thing. Did it get there? And so here, I can see the tweet itself is now combined with, that's the put HDFS. So now I have the URL that it went to in HDFS, HDFS : tweet, some other stuff we don't need to repeat. But I want to know what else it was with. So I'll look at the join itself. Rahul's tweet got combined with 403 other very interesting tweets, ideally all about NiFi, but sadly they weren't. It was just his. So there's 404 tweets that got combined together into one. That's now in HDFS. So you can run MapReduce, do your cool stuff, right? And so I know exactly which ones those are. If you want to see your web browser crash, you could say, show me all the parents, because it can now trace up the trail, down the trail, sideways, whatever. But now I also have this other side where I delivered the data to, let's look what we said to. In this case, I sent it to Kafka on the tweets topic. Right? And I know exactly what time I sent it. I know that when it got there, it was 39 milliseconds old. Again, I could look at the content, all sorts of stuff. So very short on time. There's a lot more fun stuff I'd like to show you. If anybody's interested in kind of digging into more of the details, I'd be happy to do that with you after. We have all kinds of nice statistics on each of these connections that you can look at, telling you what each node in the cluster is doing, how many bytes have been in, how many bytes were queued over time, flow files, all that kind of stuff. You can do the same thing on the processors themselves. In this case, it can tell you average task duration. It's going to be really short because that route on attributes just looking at metadata, so it's extremely fast. You can see what the average lineage duration is of objects by that time in the flow. On average, they're about, in this case, 60 or so milliseconds old. That's because I'm choosing to batch. I'm choosing to let the framework do some micro-batching for me. If I want that number smaller, then I just say go as fast as you can. Again, you're making latency versus throughput decisions. But the decisions I make are to that part of the flow. They don't affect the others, they affect that part. Okay. I'm going to hop over to the slides just to finish this off. Okay. I have a total of no minutes left. This is our roadmap. Please enjoy. If anybody's interested in talking more, I do have some time afterwards. Happy to sit down with you. There are a few people from the team and people from the community that know NiFi well. And I'm sure any of us would be happy to talk to you. But thank you all for being here.